Hello, in this video we're going to work through this problem here. Now, typically this gives students a little bit of a pause, but if we understand what our primary trig ratios are representing, this problem becomes very, very simple. So we want to remind ourselves that the primary trig ratios are representing the ratios of sides of a right angle triangle relative to a specific angle. So let's draw a picture for a second. So first thing that I want to identify is, well, where's theta? Theta is in this position right here. So what sine theta is the ratios of sides of this triangle relative to this position. The reason why I say relative to this position is because, remember, relative to theta here, the length over here is the opposite, the length here is the adjacent, and the length here is the hypotenuse. So if we remember that sine theta is defined as the opposite over the hypotenuse, what this problem is stating is that sine theta is equal to 3 over 5. That means our opposite is equal to 3 and our hypotenuse is 5. So therefore, this length here is 3 and this length here is 5. And if I know these two lengths of this right triangle, I can find the third, and the value is 4. Right away I see this is a 3, 4, 5 triangle. Now if for some reason you didn't have a 3, 4, 5 triangle, what you'd do is you'd apply Pythagoras' theorem, of course. So you'd say 5 squared is equal to 3 squared. And let's call this, for the sake of our discussion, we'll call this length x plus x squared. So therefore x squared is equal to 25 minus 9. X squared is equal to 16. Therefore x is equal to 4. And of course I've ignored the negative component because this is a length. So we know that if sine theta is equal to 3 over 5, then cos theta, which is defined as the adjacent over the hypotenuse, would be 4 over 5. And this question is done. So again, if the root of this problem is understanding what does sine theta actually represent, it represents the ratios of two sides of a right triangle relative to a specific angle. I hope this video helped.